Hello everyone, you're welcome to Messed Up Mentors. This is Python for All. This video is the last of the object-oriented programming series titled Abstract Classes. Abstract classes in Python are simply a class that cannot be instantiated on its own. It is meant to be subclassed by other classes. Abstract classes are defined by using the ABC, that is, the abstract base class module in the Python standard library. The primary purpose of an abstract class is to provide a common interface for all the classes that inherit from it. In other words, the abstract class provides a blueprint for subclasses to extend its functionality. Let's look at examples. First, to write your abstract classes, you must know that the abstract class is like a boiler template in which all the methods are decorated with abstract method. So first we import ABC, capital letter ABC, an abstract method from ABC. So ABC itself is a built-in module, okay, in the Python standard library. So now what I want to do here is that I want to generate, I have a class of different shapes. And because these different shapes share common functionality, and the two functionality I want to look at are area and perimeter. So here I will call this class abstract shape, and it inherits from the ABC in capcase class. And then all methods in the abstract class are decorated with the abstract method. What you must also note there is that in this first example, the abstract class has no constructor. We're going to deal with abstract classes that also have constructors in other examples I'll look at in this video. So I decorate this first. I say an abstract method, which I've imported, define area, self, and then end it with pass. You can either leave it this way, or you can also say raise a non-implemented you raise a implemented error 1 second, and simply just say not yet implemented. Okay, that's a not yet implemented. So you can do it this way, it's allowed. Or you can pass any comment you like. You see in the area I raised a not implemented error. Okay. And then I have another method, abstract method perimeter, and here I just pass in a doc string. So either you have a doc string or you have just a pass doing nothing. Nothing is actually implemented in the methods of the abstract class. Then I have another abstract method here, to print a string representation. So I'll just leave them this way. Now, then I will now move forward and now define my subclasses. So the first subclass I have here is a class of square, and it inherits from the abstract shape. And then I can now put in my constructor, initialize the side. The shape has one side, has four sides, but all the sides are same. So you just instantiate one side. To compute the area, I can now say self dot side all squared, and then the perimeter is 4 times self of side. And then the last method I will implement here is the string representation method. Here I want to implement how to print the information concerning the class. So I say return this is, and I call the class dot qualified name. So it returns this, which means if I call print on the object of this class, it should return the name of the class. So next I move to do the same thing with rectangle, instantiate the rectangle, also taken from the abstract shape. And mind you, you see that in these abstract classes here, it promotes polymorphism. How does it promote polymorphism? You see that the method area, perimeter, and string of the abstract class is being overwritten here. So in the same way in the square, we overwrote them in the same way in rectangle. So the abstract actually demonstrates that concept of polymorphism, as you can see, inheritance and then polymorphism, more with more emphasis on polymorphism. So having done this, we can proceed and then instantiate the object square to the class of square and side is equal to 5. Let's print square, okay, print out information on the object, and then let's print the type of square uh, dot double underscore name. Area equals square dot area. We'll call the area and then call the perimeter. If you run this, it returns this is a square, and the square area is 25, the perimeter is 20. Now let's do same for rectangle. If we run again, what will it return? This is a rectangle, and the rectangle area is this, and the rectangle perimeter is 30. Now let's try to instantiate the abstract shape, right? And then let's print shape and let's see the result it gives to us. If you do this, it throws up a type error. And look at what is happening. It's pointing first to the object shape that you have instantiated. And it says, can't instantiate abstract class, abstract shape with abstract method, string, area, and perimeter. So, and that's what we mentioned in the definition. The abstract class cannot be instantiated. In other words, you cannot create objects, okay, from the abstract class. But the sole aim of this abstract class is to allow flexibility and maintainability of your code by extending its method, okay, in the subclass. So that's what I want to demonstrate here. Let's look at the second example. I have an abstract animal, okay, class. Because you have animals make different sounds, and because the sound is common to all animals, I decided to write it as an abstract class. Okay, so I abstract the animal class, but you see here I've passed in a constructor, name and sound, and self.name is name, self.sound is sound. Now, by having this doesn't mean that you can still create object from this animal class. No, what this actually does here is that by the time you inherit from this class, it allows you either to overwrite the name and sound or to infer the name and sound from the subclass. And then you can come here and you can now call the name self.sound in your subclass. So here I have an abstract method, make sound, self, raise, not implemented, error, not yet implemented. Then I have another method, introduce. This method is not an abstract method. You can see here you are allowed to also have a method that is not an abstract method. But in most cases, all methods in the abstract class are all decorated with abstract method. Okay, so you will see the reason why if you have a method that is not an abstract method, it is difficult to override that method. Only abstract method can be overwritten in the subclass. You can only call the non-abstract method from the subclass. Let's go to dog. In dog class of dog, I inherit from abstract class. Then, of course, because this is an abstract method in the abstract class, then I can say, okay, make sound, return self.sound. Likewise, cat, make sound, return self.sound, and cow, make sound, return self.sound. Notice here that I have no constructor in my dog, cat, and cow class. So what happens is that these three subclasses will inherit the constructor from the abstract animal class. And that form you can decide to remove this. It means for every of those subclasses, you have to write their own respective constructor. So this is what we have. If you run this, then let's create an object of dog. Okay, the class name dog, and then the sound is wolf. Create for cat and for dog, for cat and for cow. And then let's run through a list of for animal in dog, cat, and cow object. Let's print animal dot introduce, and then makes animal dot make sound. If we run this, what we have, it has introduction, I'm a dog, okay, and makes wolf sound. A cat and makes meow sound. I'm a cow and makes moo sound. You can see how we have used the abstract class, to subclass and extend the functionality of the subclasses, dog, cat, and what? And cow. So let's look at the last example, example three. Example three is a bit kind of complex, but I'll try to explain and break down what I've done here. Same, I import ABC, an abstract method from ABC. Then here, the design pattern here is that I have a base class, a pizza base class that allows me to create instances of different types of pizza and also define the ingredients. And then the two method things I want to do is I want to compute the total price of the pizza, knowing the price of the individual ingredients, and also have an abstract method to get the ingredients. So I want to have a list of the ingredients for making that pizza type. So here I just pass in a doc string, returns the total price, collects ingredients. Then now I will define a class of ingredients and then inherit from the abstract pizza base. There I have my constructor. It takes a name, the pizza type, and the price. Okay, self of pizza type is pizza type, self of name is name, self of price is price. Then I will now define the compute total price method, and that returns the self.pizza price, pizza type, dot compute total price plus self.price. You see, this here calls the compute total price in the base class. Okay, and then add the price of that ingredient to it. Then for get ingredients, I will define ingredient is self.pizza type dot get ingredients, of course, from the abstract base class. And then I will append the name to it and then return ingredients. So in other words, my get ingredient in the various ingredient subclass must return a list. That's what this means. Returns a list for it to be able to append to it. So having done that, I'll move next to define the class of steak pizza. Now I want to make a steak pizza. So I also inherit from abstract base class. Initialize, all I want is just the price. Because it's steak, I know it's steak. So self.name is steak, self.price is price. Mind you, the two things I've defined in ingredient there is name and price and pizza type. So whenever we want to get the ingredient, we have to pass in the pizza type. And the pizza type comes from the class of the pizza. And then for the total price, all I need to do here is to return the price, self.price. Get ingredient, I'll return a list, okay, self.name, so that when I call other ingredient, I will append to that and I can return the names of all the ingredients. What I will do next, having these two inherit from the abstract pizza base, what I will do next is define the class of the ingredients. And that means they will now inherit from the ingredient class. Okay, so I have class of flour, ingredients. The only thing I do here is to what? Define my constructor, name, ingredient, and price, and then call super.init because the ingredient class takes what? The name, right? Look at it. It takes the name, the pizza type, and price. But here, the pizza type, what ingredient is taken is the ingredient type, not the pizza type and price. I'll do same to cheese, another ingredient, do same to olive oil, do same to onion, do same to tomato, do same to baking powder, do same to corn. All I'm doing here is just defining the constructor and then calling the super because it inherits from ingredient. The method implemented in the ingredient will be inherited by the various ingredients so that when you call them automatically, you don't have to modify them. You just inherit that method and then you can call the method. So we run this. What do we have? Now I want to have a class of steak pizza. Steak pizza. So first I will define steak pizza equals steak pizza. The price is 1001 just for the steak itself. Next, I will now have, I just want to define this the name object pizza with flour onion steak. First of all, I'll pass in flour. and then passing the steak pizza object because that's the pizza type that goes in there. And then how much is the flour? 5,001. Repeat again, pizza with flour, onion cheek, steak, cheese. The name is cheese. And what am I passing in? I'm passing in the previous object. Okay, since I, of course, what I've done here is a recursive call to since the object is same. So define all the ingredient and passing the price, all the ingredient passing the price until the baking. That's what we have here. I have this repeated once. I can remove just the one. So same here is okay. The steak pizza, everything is defined here. Then lastly, I will print steak margherita pizza cost is pizza with flour, cheese, tomato dot compute total price. And then I have it in Korean one. Insert a new line, print pizza with flour, cheese, tomato, get ingredient. So if we run this, what do we have? It returns the steak margherita pizza cost 21,400 Korean won. And then the get ingredient returns steak, margherita, cheese burst, thin crust, sweet corn. And you can see that they are the respective names of individual each of these ingredients. Now, if I want a potato pizza, what will I do? All I need to do is to define the potato pizza class, and that will take from the abstract pizza base class, right? I don't have to re-implement these ingredients; they are already there. All I need to do is to re-implement the potato pizza class, which just like the steak pizza class. So all that's what I'm doing here: the name, the price, total price, return this, and this returns the name, so that when you run, and then again I can come here and say I have a combination pizza that calls instantiates the object is a combination pizza, calls the class to potato pizza, the price 1,000. Then likewise, I'll define combination of pizza with corn, combination pizza with corn with cheese. I This is just a name, you can use any name. So I just define all the ingredients. But mind you, the first ingredient I'll first of all pass in the combination pizza object, which I've defined earlier. But in successive ingredient, I will just pass in recursively the the corresponding objects, okay, or the previous object, which is same. So that if we run this, we have it in the namespace, then we can print combination pizza cost is combination pizza with corn dot compute total price. What would that return? That will return 60,000 Korean won, and that will compute the total price. And then we can get the ingredients for combination pizza, and that will give us potato, cheese, olive oil, tomato, and corn. What the abstract based class here avails us to do is that it gives us a common interface to all the subclasses, okay, to implement their own method, their polymorphism, given flexibility and maintainability to your code. So most API calls uses the abstract classes design so that it makes it easy for any code developer, okay, that take your code, modify the code without breaking the code. Thank you so much for staying until this time while we looked at this concept of abstract classes. Share this video, like this video, leave your comments. Let's engage in the comment section. If there's any implementation you want me to do, also drop it in the comment section. I will leave a link of this notebook in the description box and also link of other resources in the description box. Subscribe to my YouTube channel if you're just coming across it and you're watching for the first time. I will see you in my next video.